downloaded that app, Genius Scan, you can just sketch on a piece of paper and then take it as a snapshot of it, and it uploads it as a PDF, and you can just turn in the answers if you want to do it that way.
I don't have Genius Scan. I don't know what Genius Scan is.
Well, you go in, do you have a iPhone or do you have a Android?
Android.
Then you go into the Play Store and you look for Genius Scan and you just download it on your phone. But that's a solution where you can actually draw on it and then take a snapshot of it.
I could just try to download the actual image and then draw on it and then put it back up.
Whatever's easier for you, because everybody's working, you know, some people prefer iPhones, and I just try to find something that works. All right, so let's go to question number 2. All right, you want to read that question for me and I'll set it up?
Okay. It says, LORAN is a long-range hyperbolic navigation system. Suppose 2 LORAN transmitters are located at the coordinates -60, 0 and +60, 0, where unit distance on the coordinate plane is measured in miles. Our receiver is located somewhere in the first quadrant. The receiver computes that the difference in the distances from the receiver to these transmitters is 100 miles. What is the standard form of the hyperbola that the receiver sits on if the transmitters behave as the foci of the hyperbola?
All right, so we're looking for the standard form of the equation of a hyperbola. So can you tell me what that is so I'll know what our target is, what we're shooting for?
Can you repeat that?
Can you tell me what the standard form of the hyperbola is so I'll know what I'm shooting for so I don't get lost?
If I'm not mistaken, that's the x squared over a squared plus y squared over b squared equals the number. Am I correct?
Yeah, you're on the right track.
All right.
But it's x squared over a squared minus y squared over b squared equals 1. The plus would be an ellipse, and the minus is a hyperbola.
Yeah, that's right. Sorry.
Okay, that's all right. That's why I ask y'all, because I get tongue-tied and twisted up. All right, so I'm going to sketch this to kind of see if that gives me an indication and makes it easier. All right, so what do I have? What are the first points that I have?
-60 and +60.
All right, so I'm just going to start at 0, 0, or at 0, and just go to the right, 60. So I go to the right, 60, and up 0. And then I go the same distance to the left, 60, -60, and 0. I have no idea what that is right now, but I do know that I'm going in the direction of the x-axis. So it's going to be a hyperbola that opens up like this. Okay, so I know that I'm going to start with x, not y. Okay.
Right.
All right, so the other two, what else does it give me? The receiver, we got a receiver over here that's kind of like measuring distance. And it's computing that the receiver computes that the difference in the distances from the receiver to the transmitters is 100 miles. Okay, so what's half of 100? Because I'm scanning.
That's 50.
All right, so if I go from 0 to 50, it's going to be somewhere like over here. So this would be my vertex. And what would this be?
The foci.
That would be one of the foci. And it would look like something like this. So now I'm getting a better idea of what I've got. And so I'd also have -50, 0. So that would be the second vertex. And I would sketch it like this. All right, so the total distance from here to here is 100. What's the distance from 0 to the vertex?
That is 50.
That's going to be A. So what is A squared?
A squared would be 50 squared. Let me pull up my calculator here.
Okay.
Just because it says 50 squared is 2,500.
All right, so I'm going to substitute 2,500 right there where the A squared is. All right, now what's the distance? We've got 0 to 60. Is that B? What is that equal to? That's actually C.
Yeah, that was C. I was just thinking that.
Okay. So we're going to have to calculate what B is. And we're going to, do you know what the formula is for that?
It was
A
B
squared,
minus A equals C.
A squared plus B squared equals C squared. So if we're solving for B squared, I think that's what you said. B squared equals C squared minus A squared.
Yeah.
Okay, so what is, we don't know B squared. What is C squared?
C squared is 60 square, which is 3,600.
Okay, what's A squared?
A squared was 2,500. I mean,
So what's 3,600 minus 2,500?
2,500 is 1,100.
Okay, so B squared equals 1,100. So let's just plug what we need into the formula. We've already got A squared here. B squared is 1,100. And then if you just rewrite this, you've got your equation. X squared over 2,500 minus Y squared over 1,100 equals 1. And you've answered the question.
So that was X squared over 2,500 minus Y squared over 1,100 equals 1, correct?
That's right.
Thank you.
Okay, is that it, or is there anything else I can help you with?
That's about it.
All right, well, I'm going to stop recording and then I'll try to send this to you, however I can do that, okay? I'll try to send it to you by email.
Thank you.